So rewriting them, numerator comes from your exponent, denominator comes from your index. So all of these, and these are all ones, but you're going to do them to a different power besides one as well. You're going to see them to multiple powers. So let's look at example 1. 125 to the 1/3, all right? That does not make sense in our brains, taking something to the 1/3 power. What does make sense, however, is if I were to rewrite it. This is my exponent, so 125 to the first power. This is my index. The cubed root of 125 does make sense. What is the cubed root of 125? There we go, and so that is my answer. All right, 5 to the 1/2, 5 to the 1/2. The problem is square root of 5 doesn't have a square root. So in this case, I'm going to simplify it just by using my exponential properties. I have the same bases here, 5 and 5. What can I do with my exponents if I'm multiplying? If this were x squared times x squared, it would be x to the 4th, right? You add them, yes? Like bases, you add your exponents. So this is the same thing as 5 to the 1/2 plus 1/2. What is 1/2 plus 1/2? 1. 5 to the first power is just 5. Okay, easy enough. For this one, neither one of these have to the 3rd power doesn't make sense. I could rewrite them. They're both the cubed root of 10 times cubed root of 100. Neither one of those have a cubed root. But what do I know about multiplying like radicals, or multiplying radicals with the same index, rather? What can I do with what's inside if I'm multiplying them? They have the same index, so I can just multiply them, right? Cubed root of 1,000. Does that help me solve this guy? It does. What is the cubed root of 1,000? 10. And so that is my answer. So you can start to see where, oh, if I rewrite it as a radical, then maybe I can just do it. Rewriting as a radical doesn't really help. I mean, I could, and it would have had square root of 5 times square root of 5 either way, but you can just go straight from here. You don't have to rewrite it. Use your properties, right? Or converting them and then multiplying them. That's going to help as well. All right, makes sense? So go ahead and do those 3. Let's talk about that. If the nth root of a is a real number and m is an integer, then, and they're just telling you what I just told you, you can go back and forth really between them here. So if I have it to a fractional exponent, I can rewrite it as a radical. Something interesting here, that m can go on the inside or the outside. This is important when you have big numbers, all right? Because sometimes it's going to be easier to take the root first and then do the exponent, versus do this ginormous exponent and then try to find the root of it. Okay, does that make sense? So it doesn't matter what order you do it in, whether you take it to the power first and then take the root, or whether you take the root first and then take it to the power. It doesn't matter what order you do it in. It's the same number, okay? This will help you with certain numbers, okay? Certain numbers are going to be much bigger and you don't want to do the power first. If m is negative, then a cannot be 0. I mean, if a is not equal to, if m is negative, a cannot be 0. So mostly because we have this guy right here. So let's look at converting to and from radical form. They're going to give us some decimals, and so we're going to convert those a little bit as well. Write the exponential expressions. The first one they give us is x to the 3/5, x to the 3/5. So again, my index is what's here. That's my denominator. Then that's going to be x to the numerator is my exponent, 3rd power. Easy enough. All right, let's look at y. All right, so for y, first of all, we have a negative, and it's 2.5. 2.5 is not a fraction. I can write it as a fraction. What is 2.5 as a fraction? 5/2. Yeah, 5/2. So negative 5 halves. All right, negative 5 halves. Now, what does a negative do with exponents? What does a negative do as exponents? What is 1? Let's see. What is m to the negative a? What do I do with that? Does that look familiar? So like 3 to the negative 1 is 1 over 3 to the positive 1. Puts it in the denominator. So 2 things here. First of all, this guy's going to be in the denominator. All right, so it's going to be, no, we don't want to erase it. It's going to be 1 over this guy because he is negative here. All right, so we're going to say that is 1 over y to the 5 halves. And then we're going to rewrite him. Y to the 5 halves. My index is 2, so that's square root. My exponent is 5, so that's that guy there. So, and I mean, they did not move him out. They're just worried about you converting it to the forms. It's not going to say, hey, then multiply times the square root of y to the 5th, and it's going to be square root of y to the 5th over y to the 5th. I'm not worried about you rationalizing it right now. I'm just worried about you rewriting it, okay? So, negative puts it in the denominator. That's very important. And if it's a decimal, just rewrite it as a fraction, all right? If it's a decimal to a decimal or something where we're going to do some multiplication, then it might not matter. But if it's like this, yeah, definitely rewrite them like that. It's easier. All right, so go ahead and write these in exponential form. How would I do it then? What is my index of this guy right here? Index. I know my exponent is 3. What's my index? 2. All right, so which one's my numerator? Exponent or index?
Wait, can you repeat
which is my numerator? Which one of these, the 3 or the 2? The 3, that's the exponent, over 2, right? Let's look at b. This guy right here, what is he going to be? B to the what? What's my numerator?
2.
What's my denominator?
Just kidding.
5.
Oh, yeah. Right.
Yeah.
I was like, what did you just say?
All right. So you can go back and forth. If it is a fraction, you can write it as a radical. If it is a radical, you can write it as a fraction. You can go back and forth. All right, so check your work on that first one. 1 over 8th root of y cubed, 5th root of z squared. For the second one, write the expressions in exponential form. So for this one, x to the 2/3, y to the 3 halves. Y to the 3 halves. Let's look at the critical thinking. Refer to the definition of rational exponents. Explain the need for the restriction. If m is negative, a cannot equal 0. We talked about that a little bit. But why, if m is negative, can a not be 0? If it is an exponential property, it also applies to your fractional exponents. The only thing you have to keep in mind is you can have a 0 in the denominator, ever, even for a fractional exponent, okay? So, which means you can't have an index of 0 for a square root, for a radical, which makes sense. All right, but if it works, it works. So you multiply like bases. That means you add their exponents. That's true even if it's fraction, all right? Fractional exponents, fine, just add the fractions. You do have to have a common denominator, but add your fractions and simplify. Power to a power. Hopefully you remember these rules. When you have a power to a power, you multiply. That works with fractions too. 5 to the 1/2 to the 4th. Multiply the 1/2 and the 4th. You have 5 squared, 25. If you have a group to a power, everything in the group is to the power. 4 times 5 to the 1/2. That's going to be 4 to the 1/2, 5 to the 1/2. All right? 2 squared to 5 is what you end up. I would probably write it like that. I mean, I would probably keep going and do this right here personally. All right? Oh, look at this one.
Oh, wow.
You have a negative exponent. It puts it in the denominator with a positive exponent, okay? So 9 to the negative 1/2 is 1 over 9 to the 1/2. 9 to the 1/2 is the square root of 9, which is 3, so that's 1 over 3. All right? When you are dividing, you subtract. That works with these, but you do have to have a common denominator, right? So we get 3 halves minus 1/2, all right? A group that is divided to a power, everything in the group is to the power, all right? So this is just a reminder of your properties of exponents here. Reminder of your properties of exponents. So then when you see this crazy big thing, you're going to be like, hang on, it's just my properties of exponents. So look at example 4. Negative 32 to the 3/5 makes absolutely no sense to our brains, right? But if I rewrite it as a radical, it will. So I can rewrite this as a radical. My index is my denominator. This is a situation where I want to take the root first because I do not want to take negative 32 to the 3rd power. Typically, I always take the root first, by the way, because it's going to make my number smaller. So I would do this whole group to the third power. So I'm going to do my index first. What is the fifth root of negative 32? Negative 2. The fifth root of 32 is 2. Because it's an odd root, we can have a negative. So I have negative 2, and I'm going to raise it to the third power. What is my answer here? Negative 8. And there we go. All right. Negative 3.5. I would rewrite that. How would I rewrite it? 7 halves, right? So 4 to the negative 7 halves, right? This is going to put it where? In the denominator. Okay, so 4 to the positive 7 halves, all right? And then I'm going to rewrite that. My index is 2, so the square root of 4, that's not a difficult one, raised to the 7th power. 7th power. So it's going to be 2 to the 7th power, which is what, 128? Yes?
Yeah.
Okay. Well, I mean, 5th is 32, so 6 is 64, and so on and so forth. All right. (16y to the negative 8 to the negative 3/4). Okay, so there's a couple ways to think about this. I would do them individually first and then go from there. Remember, you have a group to the power, so everything in the group has to be taken to the power. So I'm going to say 16 then to the negative 3/4 times y to the negative 8 to the negative 3/4. All right? And then deal with it, right? Deal with them individually. So 16 to the negative 3/4, that's going to be 1 over 16 to the positive 3/4. For this guy, I have negative 8 times negative 3/4, right? Power to the power. What is negative 8 times negative 3/4? Positive? Positive? Positive. Yes. So we're going to say y to the 6th, right? And then simplify this guy right here. This is going to be the 4th root of 16 raised to the 3rd. What's the 4th root of 16? 2 raised to the 3rd is, so I have 1/8 times y to the 6th. You can rewrite that y to the 6th over 8. That's your answer. So it's just individual ones to the power and deal with them individually. All right, so do that last example there.